everyone, welcome back to HS Tech Channel. In this video we're going to kind of have a laid back look at Db2 for ZOS, of course. We're going to look at programming, administration, kind of, not really, binding programs, running programs, and we're going to do this in COBOL and C. PL1's more or less more the same, you just have to update some of the JCL I use. I'm going to show you this interactively, but with a preference for batch, because it's way easier to deal with than trying to do it all interactively. So before we get carried away, something very important is you have to figure out how to log on to TSO. Now, this sounds ridiculous, but this field here actually matters a good bit. Now, there's different TSO logon procedures for various ZOS or OS390 ADCDs. Now, this is a ZOS 1.5 running on an old System 390 that I have. So, in order to log on to TSO and be able to do Db2, I would use DBS Proc 8, except if I was using Db2 version 8, I would use DBS Proc 8 for that, except I'm just using plain DBS Proc, which gives us Db2 7.1.0. Note that this is also true for modern ZOS ADCDs as well. Just keep that in mind, it's kind of something you have to deal with. Okay, so go ahead and log in. And first thing we need to do is start allocating some data sets. So first, allocate a SQL input and output data set. These are going to be sequential files that look like this. And this. Oh, for those of us who can spell. Alright, and you need to allocate a PDS or PDSE called the DBRMlib. And this will hold members that, think of it like Db2 for MVS was written a long time ago when they were kind of short on resources. So when you ran a Db2 program, Db2 needs to be made aware of the exact resources that it needs to run your program. So that's what we're dealing with here. That's why this exists. Okay? And assuming you're following from previous tutorials, make sure you also have the COBOL, C, and job control language sequential partition datasets. Okay, so first thing we're going to do is go back to M, and we have several options here that matter a good bit. So we have the Db2 user interface, we have the Db2 admin interface, we have query management facility, which we're not going to use. We have the Db2 performance expert, and there's a few other things we can run by typing in commands, but we're not particularly interested in those. We're interested in 11 though, because this allows us to run SQL. So go ahead and go to Spoofy up here, and go ahead and punch in your data sets for your input and output. Of course, put the quote for the TSO prefix. And then after that, go ahead and hit enter, and we're going to edit this. So we're going to create a table, and we're going to call it wc.myemp, and it's going to be derived from the same column configuration as this table here, which comes with Db2. And in case you're wondering what this name means, DSN8 is fixed, and 710 is a Db2 release, and it's like a sample table of employees. And we want the rest of that sample data, so go ahead and insert into our table all the entries that already exist. Then we're going to stuff in a new entry, we're going to display all the entries, and then we're going to commit. Now, if we hit enter, after pressing close, pressing F3, it's going to run it. Okay, and looks like everything worked, and here's our select statement. Also shows all the columns, and that's it. We're good. So let's back out, and let's talk about writing a program. Now, this can seem a bit daunting at first, but any of the programs we write need to be associated to 1. The correct Db2 subsystem, you see up here. 2. The Db2 precompiler needs to be made aware of what language we're using. 3. We need to do something called a DCL gen, so that we have a version of the table column configuration that mirrors in our program. And 4. We need to go through the build process. So before we get carried away, first thing we want to do, go to Db2 defaults, make sure the Db2 name is something appropriate, change the application language to whatever you're using. COBOL is OS VS COBOL from like the 1970s. COB2 is VS COBOL 2. IBM COB, which you may see written down somewhere as COB3. This is like the modern ZOS COBOL compiler, Fortran, PO1, C and assembler, C++. I think the rest of those are pretty self-explanatory. So just make sure you're using the correct DB2 subsystem. If you have multiple DB2 subsystems, there you go. If you're on OS 390 2.10, the DB2 subsystem name is DSM1. Okay, so Delta Sierra November 1. Of course, we're on this, so make sure your job card's good. That's for batch jobs. And I'm going to actually back out, and I'm going to show you how to do a program in batch. Then we're going to come back and we're going to look at the interactive way of doing this. I strongly don't recommend that you use the interactive. It's not very good. It actually ends up becoming way more pain than what it's worth. So let's try to streamline this. So we're going to start by writing a COBOL program. And we're going to call it SQL Cell 3 because I've already done SQL Cell 1 and 2. So here it is. It's really not that hard. So we have our identification division, okay? Then we have our program ID, our environment division, data division, working storage section. This is not a COBOL tutorial. I'm assuming you already know the gist of it. And we need to include the SQL communications area, okay? So these exec SQL statements are going to be picked up by the DB2 precompiler and translated into something else. And then we're going to include something called myEMP. And this is a DCLgen member that will generate a ton of filler fields that matches the host variables that correspond to the columns, okay? And you'll see what that means in a second. Then we have an error message string, which we actually don't need, so get rid of it. And then we have our actual program, so we need to move, remember from that insert statement we did, we need to move this to a variable called EMP_no. Now, I know what you're saying, well, we don't have an EMP_no. Where's that come from? Well, when we do our DCLgen next after this, it's going to be provided in the file that this includes, okay? And we want the employee number, the first name, the last name, and the middle initial, and we want to insert that into, well, we don't really care about the middle initial, but you can have more than what you want. It's just, ideally, you would just truncate that off into these host variables. Anytime you have a colon, that references a host variable, okay? And it's coming from the table that we created before, where the employee number is equal to our employee number here. So these are the same variables that are found in this member here. Then we're going to display that, assuming there's no errors. Don't worry, there won't be. And now we need to actually look at the JCL to do this, which, needless to say, is a bit of a mess. So the first thing we need to do is we need to run actually a TSO command, except we can run that in a batch job, of course. And this TSO command, if you're familiar with IKJ-EFT01, it just runs TSO commands in batch. You need to make sure that the step lib includes the DB2 runtime library, okay? Now remember, I'm using DB2 7.1.0, so the high-level qualifier of that is DSN 710. Define your DB2 qualifier. I'm going to split the screen. The way you do that is you just position the cursor in the middle of the screen and push up PF2. And I'm going to look for **.sdsn load. It's always called that. And you're going to see I actually have two versions of DB2 installed. I have DB2 7 and DB2 8. I can't run DB2 8. It requires a 64-bit processor. Again, I'm running this on an S390, so I kind of can't do that. And we're going to keep this open for later and open up SDSF because we're going to use this next. And then we're going to type, remember this right here is what gets typed into the virtual terminal. So we're going to open DSN, which is like the DB2 command line, and we're going to connect to the DB2 system, DB7G. Remember up on our DB2 interface, we had that on there. Okay, and then we're going to do a DCLgen here. And the DCLgen is going to create like a copy member, which I guess is kind of like a header file for COBOL that has all of those host variables defined in it, okay? So here's our table name, wc.myemp. This is where it's going to go. The language is IBM COB, which is what we want. APOST, action replace, I think that speaks for itself. I am going to go through and purge some old jobs here. And this is going to make our life a bit easier. You think I would have already done this? I don't know why I haven't. It took a while to prepare for this. I'm on the 4th retake of this video. Terrible, I know. Oh, and off you go. Oh, job's no longer valid. Perfect. Alright, submit you. And then that's going to finish. Scroll down to the bottom. And it's going to create or replace this member. Okay? Which is my EMP, the one we asked for. Okay? Now, we're going to back up. And we're going to go back to our COBOL dataset. And we're going to look at my EMP. This is what gets copied into the program when we precompile it. And this is what's referenced by those exact SQL statements. Alright? So, first we need to declare the table. This tells the precompiler what we're looking at. And then this right here is the actual definition for the entries for the host variables. Okay? So we have the employee number, first name, middle initial, last name. If you have decimals, decimals are down here. Now I know a frequent viewer of the channel / one of my many helps along this way brought up a very interesting point. How do I read this? Well, this right here means a number, a decimal number with 7 digits in the mantissa, or as one of my students said during his presentation, mantisa. And this means 2 decimal point, or 2 digits of decimal. Okay, so this would be like this. So 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay, so this is the biggest number that this can represent. Well, I guess more accurately, this would be the biggest number that this could represent. And usage comp 3 means it's going to be in a certain packed decimal format that Db2 can understand. And the COBOL compiler will automatically translate to and from that special pack form. Okay? Now, with that out of the way, and we've written our COBOL program, let's back up and let's go look at the job control language for SQL Cell 3B. Second step of this. This runs the preprocessor. Now, you can preprocess this interactively, but like I said, it's kind of a pain in the butt. It's not really worth doing. But this is honestly the preferred way to do it. So we're going to run a program called dsnhpc. Parm is going to be host IBM COB, cross-reference, source list, a post when we're done. This is where this comes from, so same place it was before. This dataset here, this syscn, this one right here, is the output from the precompiler. In this case, I'm saving this in an actual real member file so we can look at it later. Okay. This right here is the DBRM library member. You see DBRM lib. Okay. This right here is the input. This right here is our program that we wrote before. And then syslib, this is where it fetches all of those include members for that we had earlier, except for the SQL CA and SQL DA if you want that. We have a bunch of output data sets, and we have some temporary data sets. Okay, so let's back up on SDSF here, and I'm going to submit you, and then it'll take a second to run, and let's go to the bottom. Return code 4 is fine, it's just that statement contains an unknown number of in2 variables, or sorry, statement contains wrong number of in2 variables. That was, of course, this right here, just to show that it's still fine to do. If we want to make it absolutely perfect, we'll do that. And then TSO sub source.control DB, nope, SQL Cell 3B. And it will be absolutely spotless. So just keep that in mind. A return code of 4 means it's passable, okay? So return code 0 means it's absolutely perfect. So we're good. Now, let's take a look at the preprocessed version of that program so you can see kind of what we're getting at here. So this obviously got turned into a comet. When you put a star in this column here, it signifies a comet. Here's our SQL communications area. So this is like the SQL code. This right here is the primary thing that is used to report errors. This is obviously not going to be a Db2 writing applications tutorial, more of how to go through the motions of actually writing the program and making it run. So when you actually write real programs, you'll want to actually sit here and check the SQL code variable That's how you detect errors. Negative means there's errors. Okay, and then here is the my EMP member that we generated before with the DCL gen. There you go. Looks good. Okay, and here's extra stuff that the precompiler sticks in here. And then here's our procedure division. So this is where our actual code goes. And this is what that exec SQL statement gets broken down into right here. So perform SQL initial using SQL init done, blah, 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 blah. DSNHLI is the high level interface. And yeah, so it's kind of a mess. I mean, it's not the worst, but it's definitely very primitive. If you've ever written CICS macro level programs in PL1 and COBOL, this will feel very familiar to you. And don't worry, we are going to look at CICS later, just not in this video. We'll look at it in the next video, CICS and Db2. Okay, so that's our preprocessed program. So let's back to our control data set. And now we need to link it. So SQL cell 3C. Sorry, we actually need to we need to actually compile it. So here we go. Make sure you have enough region size or it might crash. Or you can just set region equals 0 for as much as your system has. This right here is your pretty typical COBOL compiler parameters. Here's the COBOL compiler load data set. Remember, the way you find it is you just search for **.sigui_comp on 3.4 on ISPF. This right here is our object file. If we have any copy statements, those will be fulfilled by members from this data set. We don't have any, but if you did, that's where we go. This right here is the input to the compiler, and then the rest of these are temporary files that are literally all the same. Okay, so we're going to submit you, and you're obviously going to take a while to run because you're a pretty serious compiler. We'll go to the bottom. Oops, sorry, I just bumped the microphone. And there's no errors here, so no statements flagged. Everything looks good, and I think there's our beautiful assembly listing. And that's it. Okay, now we need a link. So that is SQL cell 3D. So IEWL, you need the following libraries. You need language environment, and you also need SDSN load, which includes a special member for the DSN language client interface. Now, when we get to programming the CICS Db2 combo, it's very difficult to do the linking, especially on older versions of MVS and ZOS. So it's going to look a lot more precarious in that video when I make it tomorrow. So just be ready for that. And we have a temporary file. Okay, submit that. And we should be good, as always. Here we go. No sphere messages, no errors, no warnings. We're good. Okay. Now, we need to bind the program. Now, this is doable from that interactive dialog, but it can also be done from a batch job, or you can just literally type in this TSO commands and do it. So I'm going to submit you, and then you're going to finish nigh instantaneously. Come down here, bind is successful. Now let's run it. And don't worry, all this JCL is available on my website. Same thing, so we just do run program. Here's the library that's from. I'm sure you saw in the last one, I had a DBRM lib up here next to the step lib. Gotta have that. We don't need the DBRM lib for running though. Alright, we're gonna run it, and of course that's gonna happen pretty quick. And we go to the bottom, and if I scroll up a little bit, you can see there is the prompt. Come down, run it, and here's the output. Just like we expected. How quaint is that? Okay, so that wasn't so bad. Now, I'm going to show you how to do some of this stuff interactively. Not that I recommend you do it, but, I mean, you could totally do it. It's just, you probably shouldn't. We're going to start by doing a DCL gen. Hold on. Before we do that, go to Db2 defaults. Change your language to IBM COB for this, which actually I think is unironically the default, but just watch out for that. And we're going to stick you in here. Okay, so action replace, column label, no, this is good. And this right here will redo the DCL gen. Okay, And then you go and you would do the precompile. So let's precompile that. This is what we're precompiling. Now, this is going to come out of this dataset qualifier. So this is where this goes. So if you want to control where this output goes, we'll just do wec dot db2 p. Okay, never mind. I guess all we really can do is temp, and I'll show you where this gets spat out to. You can't really put it anywhere else, but the name's going to end up being wec.temp.ibmcob is going to be the pre-process output. Sorry if I sound a little bad. I'm kind of sick right now, but I guess it is what it is. Alright, so that's going to run, and looks good to me. So ignore that last error. That's like doomed to happen on ZOS 1.5. And if we back out of this and come look for wc.temp, you'll see ibmcob. There's the pre-processed program. So now you want to move this to another data set, or you would want to try to compile this directly, and that's going to produce an object file called wc.temp.obj. You would want to move this object file into a PDS or a PDSE of other object files, and then link that, okay? So it's kind of a pain in the butt. I really don't recommend that you do this interactively. And then, of course, we can also do the binding, which is necessary. So we do a bind plan for SQL cell 3. There's the DBRM lib. SQL cell 3 is the plan name. And that would be good. Now, it's not really necessary to enable and disable connections, but just kind of get used to that. You're going to have to do this in the future for CICS. Okay, and the plan was successful, and then of course we can run it as well. So that will be SQL cell 3. Now you can manually specify the plan name, but otherwise it's just going to look at the member name and pull that off. And there we go. There's the output of our beautiful program, which appears to have crashed because I forgot to bind. Well, actually, I did a rebind, a sloppy rebind at that. But anyway, you would probably just want to do that from a job. It's the recommended way to do that. Okay, now, C. Oh boy. Now, you can do a DCL gen for C. However, it produces a unusable declaration. So, instead, we're going to do it ourselves. So, I'm sure this really looks weird. I agree. It looks very weird, but I don't think it's too bad. So, here's what we got. So, first we got to have the SQL CA. Got to have it. Hood classic, right? Then we need to begin declaring host variables. Now, these variables in here will be made aware to the Db2 precompiler and are also usable in our program, okay? So our employee number is a string of 7 digits, last name is 12 digits, middle initial is just 1, and, sorry, first name and last name, there you go. And then we're going to do a little bit more complex of a program. We're going to iterate and print out every single entry in the table. So to do that, we declare a cursor. I think everyone knows what a cursor is in database programming if you're watching this. And we want to select the employee number, first name, middle initial, last name. Sorry, that was probably very loud. I just bumped the microphone again. And it's coming out of this right here. And we're going to order it by the employee number, so there is some kind of sort ordering to it. Then we're going to open the cursor. This is where you want to check for errors and do all that error checking sandy stuff that we're not doing because we're writing a bad example. And then, while SQL code is 0, go through and fetch. When SQL code is 100, that means there's no more rows, okay? So we're going to fetch the cursor into these host variables, and then we're going to print them. And eventually this loop will exit when our SQL code is no longer 0, and then we close the cursor and we return. Okay, so now we got to do the batch jobs for SQL cell 4a. This is going to do a DCL gen, so I will submit this and show you why it's not super useful. Because when we come over here and we look at our resultant generated thing, it says diabolical mess. It uses a struct. And guess what? You can't use a struct in a host variable declaration because DB2 is like, well, what is this? And it just doesn't work. Also, I know this looks weird, but this is actually perfectly valid. In order to type brackets, hold on, this is important. Because I know I have a lot of retro viewers. If you are using PCOM and you want to program in C and you want to type brackets, this is how you make this happen. Under your connection configuration, make sure that your host code page is 1047, okay? And edit your keyboard map such that these keys here correspond to, come down here to character, and you see the brackets. Assign those to base, save the key map, and then load it, and then you can actually type brackets. Otherwise, you're going to have to use the trigraphs. The reason these trigraphs exist is actually because of the mainframe, because actual 3270 terminals originally did not have brackets. Instead, they had the lazy L and the cent sign, or in this case, the broken bar. The cent sign is over here with capital 6, so it turns into a massive mess. But anyway, point is, it's better to just do the host variable declaration yourself and forget about all this other crazy junk. So don't worry about doing the DCL gen. I mean, you're going to get slightly more errors, but really it's not the end of the world. Just don't worry about it. Okay, and now I need to do the precompilation. Note that this time the host is equal to C rather than IBM COB. So I can now submit you, and this will run through pretty quick. Come down here to the bottom. Now, I didn't do any table declaration, because remember how that had the declare table thing in it? That's really only for error checking. You don't actually seriously need that. At least you don't need it now. On really old versions of DB2 from like 1995, yeah, you apparently do need that. But you don't need it on this new spiffy version. Okay, so now we've done that. We're going to do SQL Cell 4C, which is our compiler JCL. And don't worry, all the JCL is on my website. Just look in the description. And it's this diabolical mess. I'm sure that it certainly leaves much to be desired, but this is going to take the longest because the C compiler is this massive, inefficient mess. And eventually, that will run. In the meantime, I'm going to complain how much of a silly mainframe this is. It's so fun. Okay, there we go. Perfect. This is what happens when you run ZOS under an old version of VM. Performance kind of takes a hit, but it's so much easier to work with. It's way more fun, too. Okay, and you can see the diabolical garbage mess that it ended up compiling. Boy, I'm sure glad I don't have to write that by hand. If you think that's bad, just wait till you see the DB2 for VM precompiler. Whew, it looks even goofier. Okay, so that's fine. We didn't get any errors. So now let's go to SQL Cell 4D to link it. So, same thing. It will automatically fetch the link library member for the DB2 client interface. Go to the bottom. Looks good. Now we gotta bind it, which is literally the exact same thing as before. Oh, by the way, here's that DBRM lib thing that I mentioned before. So, there's our system, here's our plan, here's our member from our DBRM lib. Replace it, and the owner is me. Okay, gonna go ahead and bind that. Nobody make any jokes, please. And good. And now we're gonna run it. And this actually takes a decent amount of time to run. And here we go. So when we scroll up, you'll see all the output. Oh yeah, look at that. So much output. And it actually does sort it. Even though it's a character field, it actually will convert it to a numeric and sit there and collate it for you. So, good stuff. That's pretty much it. But there's something else I want to show you. So let's back out of all this editor junk. And let's go over here and let's look at DB2 admin dialog, which is arguably much nicer. Now, I'm in like a peon normal user, so I can't really do much here, but we can look at the DB2 system catalog if I have administration rights. So if I come up here, I actually can look at, because if I try to do anything, I don't have permissions, but I do on this terminal. And this right here allows you to query every single table on the system, and a lot of these are defaults that comes with the system, like staff, test stuff, all this stuff. These all come with the system. Here's the departments, here's the employees for this fictional company, here's the projects, here's the parts, all this good stuff. And you can also figure out what database it's in, what the columns are, and if there's any linked tables. Okay? We can also look at the databases, which conveniently, I mean, it doesn't really matter. I mean, you can do like a create database command, and then you can create a table within a database, but it doesn't really particularly mean anything. It's just that you would associate another special storage group with that database. So, for instance, if I look at storage groups, this right here is going to show you where effectively the storage group is, who the virtual catalog for that is, okay? And here's all of the collections and packages, and we can also look for plans. So here's every plan that the system knows about, and all the way down at the bottom, there's my SQL Cell 4, and there's also my SQL Cell 3 in there, and there's also packages, which you can probably guess what that is. It's like especially if you're using like an external Db2 client, this is critical to have. Okay. Also, from this user interface, as a normal user, I can use this to execute SQL statements directly from a screen input, which is very nice because it gives you this much prettier output view that's like really nice and clean. And I can even scroll left and right, except I don't actually need to because it just fits on the screen. I can also run those from a data set if I would like to do that. I can build SQL prototypes if I need to do that. And I can also, from that menu there, I can also give privileges for various objects. Like I can grant a table, like I can grant my table and I can give the following permissions. So like grant on table wc.myemp to wc, I just give all to me. So it's just like a nice little way of doing that. Otherwise you could literally just type in grant all on table wc.myemp to wcc, which obviously is not a real user. And I can also revoke from that same menu, so I can RT, revoke table. I can revoke all from this non-existent user down here. Just like that. Oh boy. Okay, I think you get the idea though. Okay. And I can also change the parameters of this program. So I can change the Db2 admin defaults, which this right here will limit the maximum amount of rows that you can fetch. You can actually set this to 0 if you want. If there's a SQL error, do a rollback, unless you want to do a commit, which you probably don't want to do. Change batch parameters. This right here will allow you to, if you do something in batch, to generate a job card or not, or just ask you to manually type one in, which is fine. Changing ISPF parameters, I mean this is just your ISPF settings option. Changing the colors, looks good. Allocating and deallocating the print data set. You can do this if you'd like to do the print options, of which you would then of course spool that to an output and then physically print it. So that's that. Db2 system administration. This would allow you to stop Db2 with like 2S, which obviously I can't do because I don't have admin rights to stop Db2. But maybe, yeah, I see I can do some things. Like the log is getting kind of full, so I might need to add a new a log at some point. DDF, this right here is remote locations. So just stuff like that. Now, in case you're wondering how this program gets started, just look for **isisp plib. Sorry, there's no S in there. This right here, this DBS ISP plib is for this right here, and IBM prods is that menu. So down here, you can see that when I type in 13, it's going to run a command called adbl. So if I do like verbatim tso adbl, it's going to open that up. Slowly but surely. Please don't hang. There we go. And if you want to manipulate that, you can do that, because that's just a C list. So **.clist. It's going to be under here. And ADBL is, I see it right there. And this diabolical mess, this is it. So this crazy insane ISPF script right here we'll get that going for you. And this is pretty much hard-coded to use whatever the current default Db2 subsystem is. Like if I find DB7G, you're not going to see it in here. So this is why you would use the correct the correct default Db2 subsystem. Otherwise, you're probably going to get some crazy stuff. So that's that. Now there is QMF, which I will try to run from here and see if it works. Sometimes it works, sometimes it doesn't work. It's kind of hit or miss. The command that it runs is QMF to SPF. Yeah, unavailable resource. Yeah, who'd have thunk it, right? Never fails. Anyway, I think that's enough. This has gone on for a hot minute, as they say. And next, in the next video, we're gonna do this all over again, but for kicks. Oh my goodness, for kicks? Oh boy, you haven't seen pain yet. This was easy. This was easy stuff. Oh boy, just wait till you see kicks. Alright, good job, y'all. Okay, hey everyone, welcome back to HS Tech Channel. This is going to be a follow-up video to the previous video where we were talking about how to program Db2 for MVS. This is going to one-up that, and we're going to look at doing this under kicks. Now, I know a lot of people watch my videos that are users of the ZOS or OS390 ADCDs, and I'm here to tell you it's a nightmare to get any of this working on there. The setup that's required is just unbelievable, and I had to have a lot of help in order to figure this out. So, here we go. We're going to talk about writing a kicks program that runs on MVS that uses Db2. We're not going to make it super fancy, so like we're not going to do any like fancy panel applications or anything like that, but we will look at a lot of JCL snippets for all of what you're about to see. So let's get started. Now before we get carried away, make sure you have your kicks terminal open, and I already have kicks pretty much ready to go, but for good measure, let me open up another terminal here. Oh. What? What the heck? Ah, there we go. Oh, that's so terrible. It's a Model 2? Oh boy. Hold on. Let me change the screen size. Make it a little bit easier to see for y'all. Okay, so I'm gonna go ahead and stop kicks here. Simply because we're gonna just kind of do it cold turkey from the start. And I don't know why my connection's hung. It's probably an SNA issue. And while that hopefully dies. There we go. Okay, so kicks is done. First thing we need to do is we need to locate the proclib member that starts up kicks. I'm gonna get the mouse out of the way. And this is necessary because we need to define a few extra things to kicks. So we need to look for the DFH-RPL program, which is where it says execute kicks, which is here. Sorry, DFH-SIP. This is the actual program itself. DFHRPL is where we store our program libraries, but this right here is what matters. We need, in our step lib, SDFHauth, SCEE run, and then the Db2 SDSN load for whatever version of Db2 that we want CICS to use. In this case, 7.1.0. See my previous video for information on how to figure out which prefix is. This needs to be APF authorized, okay? So you may need to go edit your APF list parmlib member and make sure that that's good. And then DFHRPL, this right here is going to have our dbc.source.cics.load. This right here is where we store our programs. This is just typical CICS stuff that you saw from the video on CICS. So we should be good there. So come over here to your console, SCICSA, and when that comes up, it's going to yell that there's not a functioning Db2 connection because, well, we have to define one. And so while that CICS nucleus loads up, let's go ahead and keep on going because we have much to do. So let's go ahead and write our program here. We're going to start with a simple COBOL program, and we call it Db2 CICS. I like to think that this is pretty simple, but who knows? So let us do... Actually, hold on. I did a DCL gen for this EMP member here, which is for the DSN8710 EMP dataset. So, in other words, it's the same thing, it's just the system provided one, just to show you that you can do that. So, and this second one is a C program. And don't worry, the JCL is only 108 lines, so... Okay, so here's our SQL code. The only reason that there's a MySQL code is just to demonstrate that you can, in fact, do this. Anyways, include our SQL CA, include our EMP member, which is similar, if not, it's identical to my EMP, except it just defines a different table, the one that's held system-wide, comes with Db2. And we're going to display record employee number 170, and we want employee number, first name, last name, and we fetch these into the host variables, which are declared in EMP. Okay, here's where it comes from. That's that system-wide table, and that's where the employee number is equal to the host variable employee number populated here. Then we're going to display the SQL code. Then we're going to display the last name. We're going to display the first name. Then we're going to display the last name. And that's going to come in quick succession. So we're going to need to do some kind of single stepping of the program with maybe CEDF, which is exactly what we're going to use. Otherwise, it's just going to be like bam, 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 bam. It's going to come through as a real quick blur. Okay. Now, let us compile. Now, this is going to be a bit of a doozy because this is multiple steps back to back. I'm going to be honest with you, I really don't think that this is that bad, but here's how this goes. So, first thing we need to execute is the precompiler, okay? And then we need to execute the CICS precompiler. Then we need to execute the COBOL compiler. Then we need to execute the linker, okay? So, step one is precompile. And you always do Db2 before CICS, okay? So this is the same thing we did before, except we're compiling Db2 CICS. We're going to save it in the Db2 CICS P member, so we can go back and look at that. Also, because that needs to go into the CICS precompiler down here. And this all looks good. And right here is going to be our translation step here. And don't worry, all this JCL is on my website. Worry not. And our syspunch. Let's actually store this in wc.source.cics db2 cics-t so that we can view it later with convenience. And then this is going to fetch from do that. And our object, well, we can store that in source.obj. Just like that. And of course our temporary files, can't forget those. And then here's where we are linking. So our input file here, syslin and syslmod. Syslmod, this is the data set where this gets saved. And syslin is our input file. Okay. And the rest of this is pretty much fine. The syslib concatenation here includes dsn710.sdsn load, and we need to actually tell the linker to include the dsn CLI, in other words, the Db2 client module for CICS. So let's go ahead and save that. We'll submit that. Split our screen so we can look at the output of that. And let's go ahead and march through it. So first up is going to be the precompiler. We're going to get through all the JES2 messages. Okay, so here's our precompiler. Alright, it's looking good so far. There are 0 messages. And now we're at the CICS command language translator. Here it is. Option specified is COBOL 3. That's that COBOL compiler that is equivalent to IBM COB on the Db2 compiler list. Alright, looks good. Looks like a disaster like it always is. The resident option is no longer required. And by now the COBOL compiler is running. And here is what the COBOL compiler gets to compile. Yeah, kind of a mess. Oh boy. Okay. And severity is 0, and then the linker is obviously doing this. Come down here. It's going to generate save module. No errors. Okay. Now, at this point, now that we have this, we need to go bind. So, go back to M, go back to 11. We're going to go to bind. We're going to bind. If this would hurry up and open, we're going to do Db2 CICS. We're going to call it Db2 CICS. And what you need to do is you need to say yes to enable disable connections. Okay. This is like super duper important. Come up here, put a star. Okay. And then hit enter twice. And that's going to bind it. Now, we need to go into CICS now. And we have to define all this. And this is where it turns into a colossal pain in the butt. Let me find my session B here. Okay. Clear screen. Here we go. First thing we have to do, and this oh gosh, this is going to be a lot of typing, but I'm just going to show you, and I'm going to explain it as we go. So, we're going to get errors because this stuff already exists, but it's good just to do it so we can have it. So first up, we need to define our program. So CEDA, define program, Db2 CICS, group, Db2 test. That's what we'll call our group. Of course, it's going to say object already exists in the group. Okay. CEDA, define transaction. We'll call it Db2T for test. Program, Db2 CICS that we just defined. Group is Db2 test. Object already exists. CEDA, define Db2 con. Okay, this is where it gets insane. For this to work, we have to define a Db2 connection, a Db2 entry, which associates you with the plan, and then the Db2 transaction. Okay, so we're going to define a Db2 con. We're going to call it Db7G, because that's our subsystem name. And the group is obviously Db2 test, connect error. Connection errors are going to be shown on the SQL code. The Db2 ID is, of course, Db7G. The message Q1 is CSMT. The sign ID is IBM user. Now remember, this right here is running on a ZOS 1.5 ADCD. CICS security is off, and IBM user has been defined as a God user on the system. So just keep that in mind. If you're running with CICS security on, it's going to inherit whoever you sign in as, okay? And that user needs to be authorized on the Db2 side, okay? Sign ID is IBM user. Com auth ID is also IBM user. And then the auth ID is also IBM user. Uh-oh, it's it's MSE, there's supposed to be an E there, and that worked amazingly. And obviously this already exists, but object already exists in the group. Okay, now we need to find a Db2 entry. So CEDA define Db2 entry, Db2 ENTR, group, Db2 test, we want rollback, plan name that we just found, the priority, we'll make it high, the protection number, 0, thread limit, so there can only be 10 of these running at times, thread weight, serialize it, auth ID, IBM user, object already exists in this group, okay, we got it, CADA define Db2 tran, group, Db2 test, entry, Db2 enter, trans ID, Db2T. This right here tells CICS to, whenever we run the Db2T transaction, to queue up that Db2 entry, which is of course associated with the Db2 connection, which is implicit, okay? We only have one Db2 connection active, so that's fine. Okay, object already exists in this group. Okay, CEDA install group Db2 or Db2 kit or test. Okay. Now, show you what we have so far. We have another program, another transaction, another entry. This is just for a C program that we're going to look at next. But otherwise, all of those are there, just like we entered before. Now, we need to do C and Db2 con. And come down here and note that the connection state is currently not connected. Do con, space it over, hit enter. Now if we go back over to the MVS console, you're going to see CICS Db2 attachment is connected to Db2 subsystem DB7G. Okay, back out, and now we're going to turn on CEDF so we can trace, and we're going to CEDX. We're going to trace the Db2T transaction, and now we're going to trace it. So here we go. Program initialization. Okay, now we're going to do a SQL select statement. Looks good. SQL code is equal to 0, so that's successful. And now we're going to send text. So there's our SQL code that it's printing, 0. Okay. This right here is the What just happened? My terminal just disconnected for some reason. I have no idea what happened there. Yeah, I've got nothing for you. I have no idea. Anyway, point is, I can keep tracing here. Oh my gosh. Let me do this here. Hello, do you work? Probably not. Oh boy. There we go. Okay. Db2T. Wow. PCOM just does not like this. There are so many bugs in PCOM. It's insane. Okay, reset. Okay, and the connection is completely gunned. So I'm just gonna log off. Okay. To be fair, this ancient PCOM does have several known bugs. Anyways, you saw, like, Masatoshi or whatever the guy's name was? Good, that worked. Okay, now we gotta do this again for a C program. And let me tell you, if you thought you've seen pain, you ain't seen nothing yet. Okay, Db2 kick. Okay, so it's basically the same thing. It's literally, like, exactly the exact same program. So, there you go. Don't forget for CICS, we have our DFH aid. This log panel thing, I don't know why this is here, this is irrelevant. begin with the SQL CA, declare our host variables just like we did in the last video. This right here is going to do a string copy so we can stick in our employee number, and then we're going to do that exec statement just like we did in the COBOL one. Then we're going to display our SQL code, and then after that we're going to display our string. Okay? Db2 kickja. Oh boy. Yeah, this is rough stuff. This is actually an all-in-one. This job does everything, and don't worry, I'm gonna provide a link to all this stuff. But the way this works is we start with the Db2 preprocessor. Host is obviously gonna be C, just like before. Save this in Db2 kick DBRM lib member. I love saying that, like it sounds so stupid. Here's our input right here. Now the output I'm assigned to a temporary data set because it's just spiffier. And then the input to the translator is going to fetch from this CICS. Okay, so these are coupled together. And then the syspunch, which is the output from the precompiler, goes to kickout. And then this down here is used to the input for the C compiler stage. The syslin, which is the load module, gets saved here. Syslib needs the following data sets. It needs the CICS dataset, but we also need SDFHC370. This is important because that actually contains the SQL CA member. And then you also have some macros, some samples that are just here, and then this right here is just our normal C headers. Okay, there's our temp files, looks good. Okay, and then this is where it gets weird. We have to do this copy link thing. And if we go look at this dataset here, which is conveniently named DFH lid, you'll see what this means in a second. This is used to link edit, and this is necessary to tell the link editor to fetch the client interface module, okay? And then we're going to pre-link our program. So EDC pre-link, here's our load set, and then we're going to save this in pre-link output. And then the actual linking, this is where this gets insane. So we have in our syslib concatenation the CICS load libraries, the language environment link library, the Db2 load library, our CICS library, and our input for our linker is going to come from the pre-linker output module. So here's that copy link library thing, which we're going to look at in a minute, and then this Db2 stub thing. So you need to create a member in your source.CICS, and you need to call it Db2 stub, and all that has is this. Includes syslib dsn cli. I know this is weird, but trust the process. If you don't trust me here, it doesn't work. Now theoretically you can do the exact same thing in lieu of this copy link thing, but that was just the JCL that IBM provided, so I just kind of made it work, just kind of beat it up, made it work. Now we gotta bind, normal stuff. There's our DBRM lib member. Bam. Okay. Submit. Come over here, we'll watch on SCSF. And you know this is gonna take a hot minute because there's like a billion steps in there. If you think that's bad, just wait till you see the logbook, ham radio logbook program that I wrote. Don't worry, I'll unveil that in the future when I do my ham radio with a mainframe joke video next year, along with several other interesting videos of rather interesting parlance. Okay, here we go. So that took a while. That took about 30 seconds. So, alright. Let's get down here and start with the Db2 SQL precompiler. Alright, looks good. Return code is 0, and then we jump immediately into the CICS command language translator. We go through here, we compile this absolute diabolical crap show. No messages produced by a translator. Now it's time for the C compiler. We go through all this. Okay, no errors to speak of there. Now we're gonna do a pre-link. This is the first. This equals is the first line of the pre-linker, and unresolved symbols. The language interface, the CICS interface, the C startup, and then sprintf, so we need to link those on the next one. Okay, and then the link editor down here, here's the link editor. Well, it's the binder, but it's the link editor. We're including DFH, which DFH is CICS. This is the CICS module. And then DSN, this is the Db2 module, okay? And then we have no undefined references to anything that's not dynamically linked. So there will be no errors produced by this, okay? And then we're gonna bind. All right, bind looks good. And now we should be able to go back over to our CICS terminal here. And we're going to have Db2C, which is all the same stuff, but the name has been slightly substituted before. Alright, let's do a Db2 SQL select statement. Well, that worked. SQL code is 0. Yep. And now the employee number is H, which is screwed up, but it worked. And in case you don't believe that all this is possible, you can get pretty crazy with this, really. I have an additional CICS program for a future escapade, and this right here is a ham radio logbook application, and you can see how many transactions, Db2 entries, and Db2 trans there are there. And don't worry. No, oop, hang on. Reset. Looks good. Sometimes PCOM hangs there. Update entries in logbook. If I pad through this, you can see everything. Looks good. It's quite nice. It's quite nice. We can end. Why do I have to keep hitting reset? I can quit. That's it. I told you it wasn't so bad. It's just weird. More than anything, it's just weird. And truth be told, it's a lot of fun. So now that you know this, go all out. You know, go crazy. Write you some crazy CICS applications. Show the world that mainframes aren't dead. In the next video, we're going to be looking at CICS 400. Yeah. CICS for OS 400. Yes, it's a real thing. No, it's not as easy as normal CICS. And no, the BMS maps are not compatible. Anyway, I'm going to go ahead and can it here. Hope everyone has a good rest of the day. Next video will come out very shortly.